Okay, this is the process I'm using to create a captive sphere. First thing to do, I've turned a 37mm sphere, but it's still on a 6mm shaft. There's a bit of extra which we'll come to in a minute. Now, I use a method from something called temari, which is a Japanese way of decorating balls. Temari means handball, literally. To come up with this, this is a 12 division of the sphere, which is like a D12 for gamers, Dungeons and Dragons type gamers. How you do that, you create a little, you make a tape that fits exactly around the circumference and divide it into 10. Then you mark out every line of longitude, 10 of them, onto the sphere. I check that. I've started doing that numerically because you're never going to be accurate enough with this. What I do is I do it numerically. So I measured that was 120mm rounds, which makes it a bit bigger than 37mm, and divided that by 10 and marked out those graduations using a pair of dividers so that I knew that they would all be the same. Then return that to this and marked out the divisions, scored a line every one. Now these vertices are where we're going to hollow into the sphere to leave the inner sphere. And how you find these is a formula, which is the distance between these vertices is circumference over 6 plus circumference over 100. That's from straight up from a Temari forum. In my case, that's 21.2. Now you're never going to be accurate enough to do this. So what you have to do is use as close as you can get, and then use dividers to correct anything. And the other measurement we want is this measurement up from the equator to the vertex, which is a quarter of the circumference minus the vertex distance, which is in my case 30 minus 21.2, 8.8. So originally I set a small pair of dividers, marked a centre, and then I use a very sharp point and mark in that centre. Next up, I set a compass to my vertex difference, 21.2. Oh, I don't want to change that. And I check. I will do it. I didn't want to, but for the demonstration I'll have to. So I go around every one and mark out where it intersects, and I check there that it's going to intersect with the top because we can't quite see that. So I do that on every one, go all the way around, just mark out the vertices, and you see your inaccuracies, but it's like when you're finding a centre, you can work out there'll be a point that you know is going to be the centre. So just keep going round, marking all your vertices from each point, and when you're happy with that, you'll make some corrections. When you're happy with that, that's when you come in with your point and prick out all of your final vertices. Then set your compass I decided on a hole size of 15 into these, which worked out good. Set your compass and mark out where each hollowing, like a tenon, a mortise I suppose, is going to be. So I've marked those all the way around on both poles, the South Pole and the North Pole. Next up, you can take this off. I have a chuck. And I've put this in, and that chuck's got a slot so that the thing can be angled down to bring those vertexes to the top. I should have took this chuck apart before. I'll film this, so bear with me please. Right. For some reason I did this as a chuck that fits inside my record power rather than putting a nut on the back. I prefer to put a nut on the back if I can, because it doesn't require anything else. Oh, something else I've missed. Those measurements for the height up and the vertex are marked on the back of that little Tamari ruler. It's just a paper ruler, and I use that to mark up and to set the compasses. And in fact I recorrected it using the dividers. Now before you can put that on there, there's a second piece which has to go over the thing. So I've numbered 2, 2, 1, 1, 4, 4, 3, 3. Yep. So I numbered all my jaws so that I know I can return it the same. Next up, I really didn't plan this well, is I put in, there's a few ways you could do this, but this way works just as well as the others. A centre, a very fine, that's in a pinch hook. I've just got a very good point in a pinch hook, and then what I've got to do is manipulate my sphere by angling it and twisting it until that pointy centre is right in the centre of the sphere, and it doesn't, like in that case, a little bit further that way I think. It's going to be somewhere there. No, just lock that down a sec. There, that's it. Until that point doesn't look like it's walking around a centre. Like when you use a skew to create a centre, you want that sort of consistent point on the sphere, and it's not there yet. Another way you could do this is set a platform and have a point coming in, and it's probably a better way to do it, and wait until you can trace around the circle, because then you know that your circle is going to be in exactly the right place. That would be the better way to do it, and I probably will do that before I start this one. But there you go, that's what you're looking for, is that point to not move, or to remain on your centre and not walk around, you know, turn around it. And once you've got that, I'll be turning everything off the platform. Just move this. From the face. Obviously those will be screwed in. and I want to get that as close as when I'm turning to there as I can. Now I've got to find my tool. Not that one. That one. I have a tool. The tool is double-ended like the other one. I'll tape the end up while I'm using it. Well, I have a couple of tools. I could modify this one that I used for something else. I could use any tool to come in, create a mortise. That mortise has got to be deep enough. I think it's 6-7 millimeters, so that this tool, which has got a curved front and a curved back, the curve on the that's the inside sphere diameter, and that's the inside of the outside sphere diameter. Once you've got that done, you can come in with this and start hollowing round, so that you're hollowing between your centres, if you see what I mean. And then as we do each one, and I do the next one, it's going to overlap, and once everything is overlapped, it will liberate that middle sphere. It works pretty well, and I got quite a good sphere the first time I did this on the inside. Don't know why this is stuck on there so well, but there you go. So using some combination of tools, whether they're made tools or if you can, well, that has to be made obviously, and it has to be made specifically for this size of sphere. Eventually, when it comes to parting this off, I've got that tool, which is like a right angle skew. Then that will come in along that shaft and create the same hollow for the ends, and then there'll be a little bit of fiddling to get it all to part. Well, it parted off clean the first time I did one of these, so I'm hoping there isn't any fiddling. I was expecting there to be. Oh, the other thing, I use a little dab of hot glue. Once that is positioned dead right, a couple of dabs of hot glue onto here to keep that, so to resist any temptation for it to twist or to angle in this chuck. Although it's pretty well held down when those are screwed right down. It still had a tendency to rotate in some circumstances, you know, when you get a heavy cut. What's up with my chuck here? Oh, it's not on properly. Kind of thing you got to look out for. So I'll start turning these in the second part of this, and you'll see what I mean. I hope that's not too unclear. Thanks.